Hi, my name is Sunny, and I'll be presenting our work, Fostering Appropriate Reliance on Large Language Models, the Role of Explanations, Sources, and Inconsistencies. Appropriate reliance on AI is key to safe and successful user interactions. Under-reliance can lead users to ineffectively use AI and miss out on the benefits that it could offer, but over-reliance can lead to low-quality interactions, even unsafe ones, when users are using AI in high-stakes settings, as in these examples. Mitigating risks from inappropriate reliance, especially over-reliance, is also a priority in AI policy and governance, as they can lead to disastrous outcomes both at the individual user level and at the societal level. So how can we foster appropriate reliance on AI? Prior work has explored various approaches, from effectively onboarding users during initial interactions, to providing explanations and uncertainty information, to employing cognitive forcing functions. However, much of existing research is on traditional AI models, such as specialized classification models, and we know little about how these approaches would translate for recent generative AI models, like large language models, that have these different characteristics. They tend to be general purposed, natural language based, interactive, and surrounded by public excitement, all of which can influence users' reliance. So in this work, we began with the think-aloud study to identify what shapes users' reliance on large language models, as qualitative studies can help identify what to evaluate and why. We did this by recruiting participants of diverse LLM knowledge and use and having them solve question answering tasks via multi-turn interactions with ChatGPT. The task was determining the correct answer to questions with objectively correct answers, such as general domain factual questions, health and legal domain factual questions, and math questions. From analyzing the think-aloud and behavior data, we identified 3 features of LLM responses that seem to affect user reliance: explanations of the answers, inconsistencies in the explanations, and sources that users can click on to verify the provided information. After identifying these features, we designed a controlled experiment to isolate and study the effects of these features on user reliance. Here, similar to Study 1, participants solve question answering tasks. However, this time they had access to one LLM response created in advance by the research team. More concretely, our experiment had a 2x2x2 within subjects design. We manipulated the presence of the LLM-generated explanation, the presence of sources, and the LLM answer correctness. We did not manipulate the presence of inconsistencies, but additionally analyzed the effects by annotating the presence of inconsistencies that naturally arose in the LLM responses. We created these different versions of LLM responses using the state-of-the-art LLM applications ChatGPT and Perplexity AI, and by making adaptations to their outputs. 2 things we want to note here. First, the term explanation here refers to supporting details for the answer in line with everyday usage of the term. These LLM-generated explanations are not necessarily faithful explanations of why or how the LLM output the answer that it did. These are just outputs from ChatGPT. Second, the sources obtained from Perplexity AI tended to be accurate and relevant, so please keep that in mind when interpreting the results. Drawing from prior work in HCI and psychology, we used a mix of behavioral and self-report measures. We measured participants' reliance as the agreement between the participant's answer and the LLM's answer. And we also measured related aspects such as the accuracy of the participant's answer, their time on task, source clicking behavior, self-reported confidence in their answer, rating of the statement that the LLM response offers a good justification for the answer, rating of the statement that the LLM response includes information that helps them determine what their final answer should be, and finally, whether they write a follow-up question they would like to ask the LLM. Moving on to the results. First, we found that explanations tend to increase reliance, both appropriate reliance on correct LLM answers and over-reliance on incorrect LLM answers. Here, I'm showing you plots of participants' answer accuracy when they receive different types of LLM responses. I'm focusing on accuracy because it can quickly provide insights on the appropriateness of reliance. High accuracy would signal appropriate reliance, while low accuracy, when the LLM is incorrect, would signal over-reliance. If we compare participants' accuracy when they were not provided an explanation and when they were provided an explanation, we see that accuracy is higher when the LLM is correct and lower when the LLM is incorrect. In other words, the effects of explanations are mixed. Interestingly, we also found a tension between participants' subjective ratings and appropriate reliance. We found that explanations tend to increase participants' confidence in their answer, and the evaluation of the LLM response's justification quality and actionability, even when the LLM answer is incorrect. And there are several implications of these results. First, LLMs are often fine-tuned on human feedback data, which tends to be subjective ratings on dimensions like helpfulness and preference. However, our results suggest optimizing LLMs for these subjective ratings may exacerbate over-reliance. Our results also raises the question, should explanations always be provided? Perhaps not if the user's question is hard and there is high uncertainty about the answer. On a more optimistic note, we found that sources can help foster appropriate reliance. As we can see from the plots, participants' accuracy is always higher when they're provided with sources. And even when we break down the same data as a function of both explanations and sources, we see the effects of sources are always positive. However, while the sources used in our experiment tended to provide accurate and relevant information, recent work has found that sources provided by LLMs may be inaccurate, irrelevant, or fake, which highlights the need of future work that investigates the effects of source quality. Still, when sources are expected to be accurate and relevant, it seems beneficial to provide sources and to make fact-checking easy, for example, by showing excerpts and quotes. Finally, we found that inconsistencies in explanation can reduce over-reliance induced by explanation. When we compare participants' accuracy when provided with different types of incorrect LLM responses, we see that accuracy is lowest when participants are provided with a consistent explanation, and highest when they were provided with an inconsistent explanation. In other words, there was an unexpected positive effect of inconsistencies, which is not something that is usually thought of as desirable. Further, I'd like to point out that inconsistencies are a relatively new unreliability cue in AI outputs that likely stem from LLM's stochasticity and natural language modality. Overall, these results suggest that it would be important to study what other unreliability cues exist for LLMs and to design interventions that can help users detect and reason about unreliability cues. In addition to these results, our work also contributes nuanced insights on the effects of participants' source-clicking behavior, as well as participants' interpretation of explanations from LLMs. Please check out our paper for details, and thank you for listening.